All right, we are on the home stretch of this quiz review. We are working on number 21, A, B, C, D, E, F, G, and H on the third page of the quiz review. This all has to do with this graph down here. And graphs, when you have to read off of your graphs, you just got to kind of deal with a certain level of uncertainty about where the coordinates actually are. And even with this graph, this is kind of weird because the arrows cut off right when we have some more x-intercepts. So I'm just going to extend these out a little bit further. So I have an idea of where the graph is going to go because it doesn't just end right there necessarily. All right, so the first thing says we need to determine the number of turns and state the lowest degree of the polynomial. So the turns and the degree of a polynomial are related in this way. If you take the degree value, whatever the degree is, and if you subtract away 1, that will give you the number of turns that you end up with. So this is a relation that you should memorize for exactly this type of problem. Finding the turns is really easy. All you have to do is determine how many times the graph goes from increasing to decreasing. In other words, pointing up to pointing down or from down to up. So if we start over here on the left-hand side of the graph, we can start to find the number of turns that we're going to have. So if we start here and make our way to the right, we're moving up, and then we switch from moving up to moving down. When we move from up to down, that's 1 turn. So we have a turn right over there. Then our graph is moving down, and then all of a sudden it decides that it's going to move upwards. So right over here is where we have another turn. So that's turn number 2. Now the graph is moving upwards, and then all of a sudden it decides to move downwards. So somewhere over here, we're going to have another turn. Now the graph is moving downwards, and then all of a sudden it decides to move upwards, so that's going to be the last of our turns right over there. So we have a grand total of 1, 2, 3, 4 turns. Okay, so 4 turns. And if we have 4 turns, that means that we can use this formula to find the degree. So 4 is equal to the degree minus 1. So if I just add 1 to both sides, I get my degree also. So plus 1, that means that the degree is equal to 5. So that's part A. Part B, find the x and y-intercepts. So the x-intercepts are wherever the graph is going to pass through the x-axis. So let's label those on our graph. So here's the x-axis, the one that goes left to right. So the graph's going to pass through it right there, right at the corner of the graph right here. And then another time right over here, and another time over here at the origin, and then another time over here, and one last time at the very end of the graph. So those are all of our x-intercepts. All we need to do is just label those coordinates. So I'm going to make a little column, or not column, but a row right here for our x-intercepts. I've got one over here at negative 2, 0. That's the coordinate. So negative 2, 0 is one of my x-intercepts. Another x-intercept is going to be right over here at negative 1, 0. So I add that one in there as well, negative 1, 0. I have another x-intercept right here at the origin. So the origin is located at 0, 0. And then I have another one over here. I'm going to have to estimate that value because I don't know exactly where it passes, but I'm going to guess that it passes through at about 0.5. All right, so at about 0.5, comma 0, that's another one of my intercepts. And then my last one is all the way over here on the right side of the graph, and that's going to be at 2, 0. So that's my last x-intercept, 2, 0. Now let's talk about the y-intercept. So the y-intercept is where the graph passes through the y-axis. That only happens at one point, and it looks like it's just going to be at the origin. So I add that in for my y-intercept, 0, 0. Okay, now for the intervals when the graph is increasing or decreasing. So increasing means that the graph is going to be moving up and to the right. Decreasing means that the graph is going to be moving down and to the right. So let's go ahead and determine a lot of those off of the graph, just kind of estimate how it's going. So here's the secret to getting these done properly. Always start on the left-hand side of your graph and make your way over to the right, okay? And then just be aware or cognizant of whether the graph is moving upwards and to the right or downwards and to the right. So it starts by moving upwards and to the right up until this point where it turns. So this is one of our intervals where it's increasing because it's moving up and to the right. Then the graph is going to be moving down and to the right. And it stops going downwards right at our next turn, so right over at this coordinate here. So from here to here is one of our intervals where it's decreasing. All right, next, if the graph starts turning here and then it moves upwards, it's going to stop turning right over, it's going to stop increasing right over here. So that's the end of another one of our intervals of increase. And then after it turns, it goes down. So it decreases from here to here, on our graph. So there's another interval where it decreases. And then whenever it turns, now it's going to be moving back up. So there's another interval where we're increasing. So when we're writing up our intervals where it's increasing or decreasing, depending on what teacher you have, you might be writing it out in interval notation, you might be writing it out just as inequalities, or you might even be saying just like that it's increasing from this value to this value using the x-intercept, or the x-axis. So what we're going to do is just kind of label along the x-axis where it's increasing and where it's decreasing according to our graph. So imagine that it's kind of like leaving a shadow behind. So it's increasing from here to here. So at this point right here, at about negative 1.7, the graph is increasing from any x value below it up until that point. So if we're talking about increasing intervals, then our first interval where it increases starts at negative infinity and goes all the way up to negative 1.7. So if you're using interval notation, then that means that it goes from negative infinity all the way up to negative 1.7. If you're using inequalities, then it just means that the x values that are below negative 1.7, so all the ones to the left, are going to be increasing. So that means that it'd be x is less than negative 1.7. So these two inequalities mean the exact same thing. All right, so then next, let's find our next interval. Let's go ahead and like write in a decreasing area as well. So let's go ahead and do the next one. So the next one I'm going to be decreasing from wherever I turned to this value right over here, which looks like it's at about negative 0.6, somewhere around there. So that means that I'm decreasing from negative 1.7 to negative 0.6. So if I wanted to write this up in interval notation, it would look like this. So on the left-hand side, which would be the lower number, it's going to be negative 1.7. And then on the right-hand side, which would be the higher number, that would be negative 0.6. If I write these out as an inequality, it just means that my x values are between negative 0.6 and also negative 1.7. So you can write them out either way, and I'm sure that you get points on your quiz. So after that, we're increasing again. So it increases from negative 0.6 all the way up until this next turn point, which I'm assuming might be close to 0.3. So we're increasing for when x is between negative 0.6 all the way up to positive 0.3. All right, if I wanted to write that up as an inequality, it'd be that x is between negative 0.6 and positive 0.3. All right, looks like I have another interval where it's decreasing. It's going downwards from positive 0.3 all the way over to this turning point, which I'm going to guess is like 1.6 on the x-axis, probably somewhere around there. So it's decreasing from, if I want to use interval notation, from 0.3 all the way up to 1.6. If I'm writing it out as an inequality, it looks like this. X is between 1.6 and 0.3. So these are my only two intervals where it's decreasing, so I'm done with the decreasing stuff. We have one more increasing interval, and it starts at 1.6 on the x-axis and goes to positive infinity where it's going to be increasing. So that means that this last interval where it's increasing starts at 1.6 and goes up to infinity. So in other words, when my x values are going to be greater than 1.6. All right, so that's the intervals of increasing and decreasing. Now we're going to state the end behavior. And the end behavior is, again, just how it looks on the left-hand side and the right-hand side. So on the left, it's pointing downwards. On the right, it's pointing upwards. That's our end behavior. So it goes from pointing downwards on the left to pointing upwards on the right. That's it. That's end behavior. How many times does y equal 2 touch the graph? So in other words, how many times does that line, that horizontal line of y equals 2, so that's this line right here on the graph. Let me make sure it's in focus on the video there. There we go. How many times does our graph pass through that line? It looks like it passes through once here, and once over here off the graph. So that means I'm going to have 1, 2, 3 times when it intersects. So that means 3 times is when it's going to pass through that line. Estimate the value of f of negative 1.8. So we go to negative 1.8 on the x-axis, which would be right here. And then it looks like the coordinate is going to correspond with, let's see here, where on the y-axis? Like maybe somewhere over there. So I'd probably say that that's pretty close to, I don't know, 4.5 or 5 or something. So if you're anywhere in the ballpark of 4.5 to 5, when you write that down, then you're okay. Like, look, these graphs, you kind of have to estimate where these values are. So I'm sure that every one of your teachers is going to have like a kind of like a margin of error that we're going to have for these particular answers. Is f of 1 positive? So in other words, where x is equal to 1, so x is equal to 1 on this line, where does it coincide with the graph? Right here. Is this y value going to be positive or negative? Well, since it's below the x-axis, it's going to be negative. So negative is our answer there. Next, state any local minimums or maximums. So you know all those turning points that we had? Those are the maximums and the minimums. So there's 1, 2, 3, 4 of them. And I like to think of them like this. The minimums are the ones that are at the bottom of the hill, so like ones that look like that. And the maximums are the ones that are at the top of the hill, so ones like that. For these particular graph problems, you just have to estimate where they are. There's no like rhyme or reason to any exact answers, but just make sure that they're kind of in the right ballpark. So our first turn is at negative 1.7, and maybe that's at, I don't know, 6, pretty close to 6-ish. So is this a maximum or a minimum? Well, it's at the top of the hill, so that makes it a maximum. So our first maximum is the coordinate at negative 1.7, comma, maybe 6, pretty close to 6. All right, now let's talk about a minimum, because the next one that we have down here is a minimum, because it's at the bottom of the hill, so this is a minimum. So at that point, that's where the x value is negative 0.6, so negative 0.6. My x value, my y value is probably pretty close to negative 2, so I'm going to write negative 2 in there. All right, next, another top of the hill part, so that's a maximum. So that coordinate's located at, I'm going to guess, probably 0.3 for the x value, and then for the y value, maybe about like 0.5. Man, these are really kind of lame coordinates. Hopefully on the quiz, they're going to be nice lattice points, so like, on corners, so you can find like exact values for them. And then our last coordinate that we have is this minimum right over here, so that's where the x value is 1.6, and it looks like the y value is, I'm going to guess it's, right around negative 13. It might be a little off, but, I can kind of estimate. All right, so these coordinates are the minimums and maximums, and that completes the last page of the quiz review. So, since that's the end of it, good luck on your quiz tomorrow. Go in for help if you need help tomorrow morning. And I'm pretty sure ACLab is tomorrow as well. So, just call, ask for some help in ACLab also. But good luck on your quizzes tomorrow, and have a nice day.